Hey, Algebra 1. Hope you guys are doing well. Just look through a few examples here in 2.2, which is one-step equation. So make sure that you have your note sheet out for 2.2 so you can write and fill in our notes. 2.2 is on one-step equations. And I know that you guys have worked with one-step equations before, but we're just going to review it and kind of build a foundation. So on the top, you can see that our learning target is I can use the properties of equality to find the value of the variable that makes an equation true. Now, the value of the variable that makes any equation true is just simply called a solution. And so what we'll be doing is just solving equations. So a few definitions on the top that we can just briefly mention. Number one is an equation, and we talked about that yesterday. An equation is simply two expressions that are connected by an equal sign. Once you put that equation sign in the middle of two expressions, now we've created a constraint, and now x can be something specific. X can be solvable. Number two, a solution to an equation is a value that makes an equation true. It's a value that makes an equation true. And typically there's only one solution to each equation or linear equation that we'll see. Number three, equivalent equations. Equivalent equations would be two equations with the same solution. So for example, if I had two equations right here, I had 2x equals 10, and then I had another equation that was 4x equals 20. These two equations look different, but they have the same solution. Um, x is still going to be 5 for each one of these. X is 5, x is 5 for this one. So they have the same solution, so they're equivalent. The third thing we're looking at here is to solve an equation. The process of solving the equation um, is, sorry, I'm going to say that again. The process of isolating a variable to uncover its values, finding all values of the variable that make the equation a true statement. So we're going to be getting x by itself, getting the variable by itself to uncover what its value is equal to. Now, below this, the second part of this front page is some properties of equality. And I call them, they're pretty common sense properties. I'm going to have you fill these in, but I'm going to briefly talk over them for a little bit. So, for example, um, the addition property of equality. Okay, what does the addition property of equality mean here? Well, oops. The addition property of equality simply says that if I have an equation, let's just say we start. So in our notes, I just put like x equals x, which is obvious. X is equal to itself. That's reflexive, right? If I have x equals x, and then I simply add the same number to both sides of the equation, then I haven't really changed x at all. X is still the exact same solution. The equation looks different, but these two things are equivalent equations, right? So also, with this analogy, you can think about a scale or like a seesaw, right? If you have a seesaw or a scale on left and right, and you put two 10-pound weights on the left and right, that scale would be perfectly balanced, right? And that's what an equation represents. It represents the same thing on the left and the right. You have a balanced scale. Now, the addition property of equality, just like all of these properties, say if I do something to one side and I do the same thing to the other side, the scale will still be balanced. So if I had two 10-pound weights and now I drop a 5-pound weight on the left-hand side, and I also drop a 5-pound weight on the right-hand side, then the scale wouldn't move. It would still be perfectly balanced. And that's all these properties of equality are saying. So for example, if you look at the subtraction property of equality, if I have x equals x and I subtract a from both sides, I say x minus a equals x minus a, subtract the same thing from both sides, well, that means that those equations are equivalent. They're going to have the same solution. Multiplication property, same exact thing. If I multiply by the same number on both sides of the equation, then I'm going to have equivalent equations, or I will keep my equation in balance. The division property of equality over here, x equals x. If I divide both sides by the same number, I'm going to have the exact same solutions to the previous equation. And you can see the examples below, the numerical examples, and they should make sense to you, right? So um, I didn't go over those, but for example, look at the multiplication. If I have x equals 3, and then let's just say I multiply 8 on both sides of the equation, right? If I multiply 8, then I would transform my equation to 8x equals 24. Now, the solution to that is still x equals 3. I haven't changed the solution to the equation. The equation is still an equation, still balanced. So that just shows you that this doesn't change the value of x. No matter what I do to both sides, as long as I do it to both sides, I'll have equivalent equations. So that's the first part of our notes. Just make sure you write down the initial stuff here. This is also posted on your agenda. So if you need to fill it in, you can just open that up and fill in some of this vocab here.